Chapter number 10.3, Forces and Acceleration. We discussed initially about this. This is about this Newton's second law. We discussed if we uh, proportional to m times a, then F equal k ma. So then k is a constant and equal to 1. So F equal ma. And then assume that a particle m fall under gravity with g ms minus 2, then the force F is, when we put force, let's say R, so this F equal ma to when we put downward, so this R equal m times acceleration is d. So the downward force is mg. So this R is especially called the W. R equal W equal weight. So basically we can use this as a formula. W equal mg weight. If we need to find, you want to multiply by the acceleration and the mass together. As we discussed earlier that this is a vector equation, so we have to show the direction, which direction we are going to apply this F equal ma. So in here, so I apply F equal ma to downward for this particle. Let's discuss example 5. So assume a particle on the air and it has 6 Newton force, and this is given 1.5 kg kilogram, and we need to find the acceleration. Now, to which direction we need to put F equal ma? It is clear that the forces in this, actually I draw according to the horizontal. So this is horizontal force. The direction of F equal ma should be to this direction, because this is a horizontal force, and then the acceleration also along horizontal towards OX direction. So F equal 6 Newton and M equal 1.5 kg. Then we will apply here 6 equal 1.5 times A. 1 point times A equals 6. I wrote again because X equal Y, then Y equal X. So A equals 6 divided by 1.4, that is going to be 4 ms minus 2. Assume in this sum, acceleration is given, that is 4, and we need to find m. Still the same thing, when we look at it is moving to this direction. So F equal we know, m we don't know, A equal 4, so m equal 6 divided by 4, 1.5 kg. Now assume A is given, M is given 1.5 kg. Now we want to find F. So F equal the force M times 1.5 times 4, which is 6 Newton. So we work anything. So one equation, there should be one unknown, then we can solve. So we work this sum. It was in the air and there is no restriction, air restriction, and under these assumptions. And now I am going to keep this force in a, keep this particle in a smooth space, smooth surface. Now you can see, so I will give this weight is 1.5 kg, m is 1.5 kg. Then you can see that two surfaces touch together, the marble surface or the particle surface and this surface. As a result, we will get R and the weight is mg. I only consider this surface, not the particle, not this surface. Now question is A. Find the acceleration. Now you have to consider, because you can see horizontal and vertical forces. Then you have to consider two accelerations, initially horizontal and a vertical. So I can see that when you consider horizontal, you have only one force, that is 6 Newton to this direction. But when you consider vertical, you have two forces, one is R, another one is to this direction, mg. So then either it go up or down, or it should stay in the same place without without flying or without sinking. Basically, we have two acceleration now. One is, let's say, a1 to this direction, or if it is minus other one, and a2 to this direction we are expecting. Now we'll put F equal ma to this direction for the horizontal force. So only one force there, 6 times m we know 1.5 given, and a is a1. So a1 equals 6 divided by 1.45, that is 4 ms minus 2. Now we'll put F equal ma to any direction up or down, but I will select up. So now forces. So how many forces there are in this direction? Okay, this is R on this direction, positive. So mg in the other direction. So then this is going to be negative because I turn into the other way around. And m is 1.5. And a2. Do you know this is moving upward or downward? It means flying or sinking. When you keep a particle on your floor and when you give a horizontal force, it doesn't fly or it doesn't sink. It just move to this direction, the direction of the force given. So A2 in this case, since it's not moving up and down, A2 equals 0. So this is going to be 0. Then R minus M, actually we know M is 1.5 G. This is 1.5 G. 1.5 G equals 0. So R equal 1.5 G. So now we have a benefit of applying F equal ma to upward or downward, because as a result we were able to find the reaction, normal reaction. That normal reaction is equal to 1.5 G. We know G is going to be 9.8 as usual. Now we know the acceleration in this direction. So it has only one acceleration, one side. It is horizontal to this direction, and we also found out R. Now that's done. Now Here I use a smooth surface. So what is the data you can obtain from the smooth surface? If the surface is smooth, then there is no friction force. But if I keep this the same thing, 6n, so this is R and mg, and now this is a rough surface. Then as this, because of this roughness, you will have a friction force from here. So it may be 2 or 1, or usually we refer as F. So now this is, since this is rough space, so I will mark, actually it should mark here, but for clearness I mark here, and I will give 2 Newton friction force. So M equal is still the same, that is 1.5 kg. So this is 1.5 g. Now find the acceleration. Still we have two setups. So F equal ma. So one is horizontal acceleration, other one is vertical. Because we can see why only horizontal and vertical, because I can see only horizontal and vertical forces. If we have this one and another one, so I have to consider every possibilities. Instead of that, we are doing a different technique. So 6n, 4n, and if it is 7n, then sometime I might put F equal ma to this direction. But we don't do that. We will do separate. We will break these two into the horizontal and vertical and horizontal, and we work out. We'll discuss soon now. Now I have to select either this side or this side to put. Usually I can see when I look at this is more stronger than this is Newton. More stronger than 2. 6 is powerful. So F equal ma to this direction. So there are two forces, vertical, horizontal, one and this one. So this is plus 6, and this is, I'll turn into the other way around, put in minus, and then m is 1.5 given, and a is let's say a1 to this direction, and this is a to this direction. So a1. So this is 6 minus 2, 4 equal 1 point times a1. And so a1 equal 4 divided by 1.5. Now we'll put F equal ma to, it can be up or down, but I use up. So then two forces there, one is R, other one is opposite 1.5. I'll turn into the right side, put in minus 1.5 g. M is will given 1.5 times. What is A2 now? Oh, just A. So there is no acceleration on any side. It is not flying nor sinking. So when you keep a marble on your floor and when you drag horizontally, so it's not flying or sinking. So this is 0. Then R minus 1 point G times 0, R equal 1 point G, R equal 1 point times 9.8. So we put F equal ma, we managed to find the acceleration, same F equal ma, and we managed to find the normal force. Actually here we know A2 acceleration is 0 because it's not moving. So in here also acceleration is 0. We know that's not moving, flying, no sinking. If I summarize again, so in here we know we can find the acceleration we don't know. Here we know the acceleration, and as a result we can all able to find the normal force R. So now for both setup, if we need to find the acceleration, we have horizontal and vertical. So horizontal we need to find, vertical is always 0, it's not moving, and here um, horizontal and vertical, horizontal we need to find, and vertical is not flying, no sinking, 0. Now when we put F equal ma, we can find A1 here. So when equal F equal ma, we can find R, because we know that A equals 0. So that is the benefit of it. And this is F equal ma, when you put, we can find A1. And since we know that A is 0, when you put F equal ma, we can find R if in this setup. Let's consider this one. The weight is 2 kg, and I put 6 Newton force here, and other 4 Newton force in this direction, and find the acceleration. Now it is clear that this direction there is a force, and this direction there is a force. Then we have to consider two acceleration, a1 ms minus 2 and a2 ms minus 2. Now we'll put F equal ma to horizontal. So to this side. Um, so then force to this direction 6 and weight is 2, and let's consider that is a1. This is 6 divided by 2, 3 equal a1. a1 equal 3 ms minus 2. So it has a 3 ms, and then we'll consider the vertical acceleration. So F equal ma to upward, then this is 4 times m is as usual to the acceleration in direction a2. So then a2 equal to ms minus 2. Then we need to find the magnitude. So in this particle we have this one 3 ms minus 2, in this direction 2 ms minus 2. Then we want to find the magnitude. So magnitude is, this is 3 and this is 2. So this direction, this is 3 square plus 2 square, square root 9 plus 4, square root 13. And then the angle, if we, this is theta, so tan theta equal 2 divided by 3, theta equal tan inverse 2 over 3. Or we can work like this. First of all, we'll find the resultant force. So resultant force is, this is 6 Newton and this is 4 Newton. It means this is a rectangle. So because of that, this is 4 Newton, this is 6 Newton. This one is going to be, let's say R equals 6 square plus 4 square, square root. So that is 36 plus 4 is 16. Square root, that is going to be 3652. Now let's find the direction of the force, that is tan theta equal 4 divided by 6, that is 2 divided by 3, theta equal tan inverse 2 over 3. So it should be matched with this one because the particle is accelerating towards the resultant force. This is the resultant force. So particle is accelerating in this direction. Because of that, the acceleration direction and force direction has to be same. That's why. Now our object is find the acceleration. Now we'll put F equal ma, not horizontal, not anything, to this direction with the theta, angle with theta. So then F is, we know, for this direction is square root 52. M, we know this is 2 kg. And A is A. So this direction will take A, the same magnitude A. So A equal square root 52 divided by 2. So this is 4 times 13 over 2. This is 2 square root 13 over 2. 2 to 2 cancel out. Square root 13 ms minus 2. So now, as a summary, now we work out the acceleration. We work as a components. This is a horizontal component, and this is vertical component or x component and y component. And then we find the magnitude and the direction. Or from the force, we know that it is moving towards the resultant force. So then we find the resultant force first and the relevant direction. And when we put F equal ma, then we can find the uh, acceleration, and direction is same, tan inverse 2 over 3. Sometimes you may have this one in, they may given in F equal 4i plus 6j and m equal 2 kg. So find A. Then if it is given in this form, so you can simply work with, so this is how it is. F equal ma to, so we don't mention any direction because it is a vector form. 4y plus 6j equal m times, that is 2 times a. Then a we will get 2i plus 3j. So I wrote differently in a wrong way. This is wrong. This is 6i plus 4j because this is 6 and this is 4. So 6i plus 4j, then this is 6i plus 4j, that force F. Then you are dividing this one, half of 6i plus 4j. So this is going to be, you can multiply by, this is going to be 3i plus 2j a. So then you can work in this form. You can see this is a equal 3, this is equal to, then you want to find the magnitude. So then you are finding mod A. So mod A is this, this is the mod A. So magnitude. Then you need to find the direction. So this is the direction. Usually it will given in this form. So if you get this particle, and this is 6 Newton and this is 4 Newton, and if you keep 6 Newton and 4 Newton, this particle move on this direction. Also, as far as you keep 6 Newton, 4 Newton, so 6 Newton, 4 Newton, 6 Newton, 4 Newton, 6 Newton, 4 Newton. So you maintain that every time 6 Newton, 4 Newton. So it will move this direction. We found out theta equal tan inverse 2 over 3. And it means this side is we have the acceleration 3 ms minus 2, 2 ms minus 2, 3 ms minus 2, 2 ms minus 2, 3 ms minus 2, 2 ms minus 2. So this is 2 kg. So this is what is happening. So those are the in terms of the forces. This is the horizontal force. This is the vertical force. This is the horizontal acceleration, and this is the vertical acceleration. So because of these two forces, it is moving along this direction, and we get the resultant force is 6 square plus 4 square square root, which is square root 52, and resultant acceleration is 3 square plus 2 square square root 13 ms minus 2. This is Newton, and this is the angle. Example 6, part A. This is 2 kg, and this is x, and this is 4 Newton force here, and this is acceleration to this direction, horizontal not vertical, and this is y, and this is 2n. So we will put F equal ma to this direction. There are two forces. One is x positive, if you, and this is negative since selected this side is positive. Equal m is 2 times a is given 2. So this is x minus 4 equal 4. So x equal 4 plus 4 equal 8. So we will able to find the uh, x value. Now f equal ma to upward, because we know that a is given here, because it is only moving to this direction, mean this direction velocity is 0. So f is, okay, this is positive, we have y here, y minus 2. So those are the only two forces, and m is 2 and a is 0. So y minus 2 equals 0, y equals 2 Newton. This is 2, and because it is 2g given, so then this has to be 2g actually. Then this is going to be 2 times g, which is 2 times 9.8, that is 19.6 Newton. This is part B. So it will tell that it is acceleration to this direction. Then it will obviously tell that, indirectly tell that, so this is 0 acceleration to up or down. So we can see that it is moving this direction. This 80 is more stronger, I believe. So F equal ma to this direction. So 80 minus x. So this is 80. There are two forces. One is 80, another one is x. So 80 minus x. M is given here like 4. So 4 times a is, we know, 2. So this is 8. 80 minus x, so x equal 80 minus 8, that is going to be 72 Newton. Now F equal ma to upward or downward, I put upward. F is y minus 20 minus 4j a quick 4 times acceleration is 0, because it's not moving on this direction. Y minus 20 minus 4g equals 0, y equal 20 plus 4g. So 20 plus 4 times 9.8. So this answer is 59.2 Newton. Example number 7. Body of mass 5 kg along the rough pulled along the rough horizontal space. It means it has a friction. So this is 5 kg. So this is pulled with the force of 20 Newton, and the frictional force is given as 4 Newton. This is the surface, and this is 5 kg. So because of that 5g on, and then there's a normal reaction. The part 3 of this question is to find the magnitude of the normal reaction. So it is so simple. When you put F equal part 3, I am working MA to upward. So we know that it is moving along horizontal, not flying or sinking. So A is 0 for this direction. So then R minus 5 G equal M is 5 times A is 0. So R equal 5G. 5 times 9.8, and that is going to be 49 Newton. So that is an easy one. So always when you look at this system, R is straightforward if it is moving like this horizontally. Now, the first part is find the acceleration of the body. So then we have to put F equal ma to horizontally any direction. So this is 4 and this is 20. This is strong. Then it should move to this direction. So I'll stay with that. So two forces plus 20 and negative 4 to this direction. M is 5 times A we can find. So 20 minus 4, 16 equal 5A. A equals 16 divided by ms minus 2. And this is part C, this is part A, and then part B. So part B is the question is the distance traveled by the body in the first 4 seconds. So now we are constant acceleration formula we have to use. So S equal ut plus half a at square, v equal u plus at, v square equal u square 2s, and s equal v plus u over t. So that is so those are called constant acceleration formula, because in here we consider that acceleration is constant. We discussed this one earlier. Now to find the second part, the distance traveled by the body in the first 4 seconds. So then first 4 seconds, so we have the acceleration now. A equal 16 over 5 ms minus 2, t equal given 4 seconds. So we need to find the distance. So s. Then what is the best fit for this one? Out of that, the best fit is s equal ut, because u also given starting from rest. S equal ut plus half at square to this direction. So S equals 0 times t is 4 plus half a is 16 divided by 2, t square equal, which is 4 square. So S equal 25.6 meters. I don't like this to purposely, because sometimes in the sum they may give the opposite way. So we don't consider this one. Now for example, they will give, they don't give A. Then they will give all the data, then they will give the distance also 2.6 meters. Now you have those data. Right? Then they will ask, uh, find the weight of the particle. They will tell the story that the particle which W m weight is acting on those ones, and this particle stay at the rest, and after 4 seconds it will go 25-second distance. Find the weight of this particle. So then you have to put S equal ut plus half at square, then S equal 24 and 6, u is 0 times 4 plus half a times 4 square. Then you want to find a. Then you will get 16 divided by ms minus 2. Then you put f equal ma to this direction. 20 minus 4 times m times a is now we found out 16 divided by 2. Then 16 equal m times 16 divided by 5, and 16 cancel out, m equal 5 we found out. So this is the inverse of the sum. Let's discuss 10c now.